Hey guys, what's up? Hope everybody's doing well. Before I jump into number one, I just wanted to make sure everybody's aware of the information that I posted the other day on Google Classroom regarding the AP test. Looks like the test is going to be May 15th at 4 o'clock our time. So mark your calendars and make sure you have internet and you are ready to rock at 4 o'clock. There's also some additional information about the kinds of questions, the style of the questions, and the timing. So make sure you read through everything here so you're well aware of what to expect on test day. Basically, this highlights what you need to know. There's two questions. The first question is going to be 25 minutes, and it's all about arrays and array lists. You should be cool with that. The second question is going to be a little bit shorter, 15 minutes, and more like the question that I'm about to go over with you today, which is why I picked that question, because I think it looks a whole lot like the kind of question that you should expect to see for number 2 on the AP test. So number 2 is basically about methods and control structures like loops, if statements, those kinds of things. So if you read through all this, and if you have any questions at all about the AP test, just don't hesitate, shoot them my way, okay? All right, let's jump into number 1. So we have a frog simulation class. Let's just, before reading the question, let's just run through the whole class and make sure we understand what we have and what the class is comprised of. So we have the frog simulation class. Looks like it has 2 instance fields. One is the goal distance, one is maximum hops. Both of them are integers. This is the distance we're trying to get our frog to hop. Okay, and this represents the maximum number of times we're allowing our frog to hop. Our constructor just takes in 2 things, and it initializes the goal distance and the max hops. That makes sense. So our 2 instance fields get initialized. We have a private int hop distance. So hop distance, I have no idea how it works, and I don't care. It is going to return an integer that represents the distance in inches to be moved when the frog hops. So I don't know exactly how it works, but it's going to return to me an integer. I think later on it will explain it can be negative, positive, or 0, I suppose. So it will just return some distance, and I'll have to use that in my methods later on. So let's see. This is what we're going to do in part A, public Boolean simulate. This is going to return true or false, whether or not our frog was successful. And then in part B, we're going to code up this run simulations, which returns a double, and that tells us the percent of simulations that were successful. So that makes enough sense. All right, let's jump into A. Come on. Okay. Whoop. Try that again. So I don't want to read all of this to you. In part A, basically we're trying to code the simulate method. And here are some examples of this simulator. So we're trying to go 24 inches, and we're trying to do it in 5 or fewer hops. So this is a successful simulation right here. I went 5 inches, then 7 more, then I went backwards 2, forward 8, forward another 6, so I wound up going 24 inches at the end. On my last hop, I was successful, so that should return true. 6, 7, 6, 6 doesn't even need the 5th hop because I hit or went beyond my 24-inch goal. So that's an important note, that we should shut the simulation down early and not run all 5 jumps, because if our next jump goes backwards, we might register that as a fail, but it shouldn't be because we did hit our goal. In example 3, let's see, we have 6, negative 6, and then forward 31, huge hop. So we hit 6, and then we went back to 0, which is okay, and then we jumped 31 inches forward, so that is successful. You are allowed to hit 0, that's why this example is here. You're not allowed to go negative, and that's why this one's going to be a fail. We went from 4 to 6, and then backwards 8, so we're actually at negative 2, and as soon as your frog goes negative, we're supposed to shut down the simulation. That's a fail. Here's another fail because we went from 5, now we're at 9, 11, 15, 18. We maxed out at 5 hops. We did not hit our 24-inch goal, so that's a fail. I hope that you ran through the examples to understand exactly how the code should run. And this is what my code looks like. Here we have public Boolean simulate. First thing I'm going to do is create an integer that represents where my frog is at any given time through the simulation, his position. And then I'm going to set up a loop. Now, I think a lot of people probably would have gone with a while loop for this. I just love me some for loops. I would always do a for loop, and I'll just have my return statements in there if I should get out early. So for I equals 0, I is less than max hops. It might even make more sense if you go from 1 to less than or equal to max hops, whatever, as long as you are maxing out at max hops times through your loop, if that makes sense. So go from 1 to max hops, or go from 0 to less than max hops. I may get out early, like I said, if I hit my mark, and then I'll just return true. Or I go through as many times as I'm allowed to, which is max hops times. I'm going to update my position using hop distance. Now, they definitely went out of their way to make sure I know that it is available to use. It says it somewhere in here. Yeah. So the frog simulation class provides a method called hop distance, telling me I have to use that. Why wouldn't I? So hop distance, again, we don't know how it works, but we don't care. All we know is that it's going to return some number. It might be positive, it might be negative, it might be 0. Who really cares? Whatever it is, add it to our position. And now check to see if we've won the simulation or if we went behind 0, if we went to a negative inch. So let's see, if position is greater than or equal to our goal, just return true, get the heck out of Dodge. Else, if our position is negative, return false. Do not continue the simulation under either one of these conditions. You don't want to continue the simulation here because you might accidentally go back to the left of our goal. Or I might wind up hopping back over 0 and back to where things are positive, and we don't want to accidentally do that. If I go past my goal or hit my goal, you're done. If I hit a negative inch, you're done. So use your returns. If I finish this entire loop, then I'm just going to return false. If I had hit my goal distance, then this would have triggered and I would have returned true. So the fact that this loop is done and I'm still running the simulation means I don't really care where I am. I just definitely didn't hit my my goal. So return false. So this was a 5-point question. Your first point is for using hop distance. I know this is the first check mark I have here, but if I'm remembering the rubric correctly, the first point they're going to give you is for utilizing the hop distance method and using it to update your position. So you kind of have to do both of those things to get that 1 point. Use hop distance to update the position of your frog. That's point 1. Second point is somehow in the context of a loop, maxing out at max hops. So either go from 1, like I was saying before, either go from 1 up to and including max hops, or from 0 to less than max hops. Somehow in the context of a loop, a for loop or a while loop, whatever makes sense, make sure you don't do more than max hops. That's point 2. The third point and the fourth point are for getting yourself out of the simulation early if you hit your mark or if you went negative. So 1 point for each of those returns, not the return statements actually, but for the conditions, I guess, that would trigger the returns. So if you check to see if your position hit your goal, give yourself a point. If you check to see if your position went negative, give yourself a point. The fifth and final point is for as many return statements as you need to have. I have 3 separate ones. If you designed it some other way, I can't imagine having less than 3. Maybe you have more. As long as all of your return statements are correct, give yourself another point. Okay, so that's part A. Part B. Part B seems more straightforward. We're just going to run the simulate method over and over and over again, however many times we're supposed to, and see how many times we were successful. So that's easy enough. Public double run simulations. This is the number of times I'm running my simulation. You're going to get a point for establishing some sort of counter, an integer that counts up how many times you were successful or how many times you won. And then you're going to set up either a for loop or a while loop, whatever, that runs that many simulations. So a second point is for somehow, again, in the context of a loop, correctly setting up a construct that will run your simulator the right number of times. So like before, this could go from 1 to equal to num or from 0 to less than num, as long as it runs num times somehow. Again, either it's a for loop or a while loop, it doesn't matter. As long as you have some sort of loop that runs num times, give yourself a point. Inside of that loop, if simulate equals true, or you could also just say simulate. Sometimes I like explicitly stating the equals true part, but you can just say if simulate, then wins goes up. Increment your wins counter. So if simulate is true, wins plus plus. Finish that loop, and then you'll get 2 more points outside of this loop for returning. 1 point for returning wins divided by num. Another point for making sure it is a double. So be sure you cast wins to a double. Now maybe you just made it a double up here, and that would satisfy that point. If you made it an integer, then just make sure you cast it to a double, and then divide by num and return that decimal. So there you go. That's 4 points for part B. If you have any other follow-up questions on this whole problem, just shoot them my way, and I'll talk to you guys soon.